Welcome to clickmyproject.com.
We will discuss about the product for test computation by sharing of transparent scan sequence among logic blocks. Next, we will see the abstract for the product. An approach to test application called transparent scan provides an opportunity to share the test among different logical blocks whose primary input and output are included in scan chain even if block have different number of state variables. A transparent scan sequence for one block is likely to detect fault in other blocks since transparent scan does not distinguish between the functional and scan clock chain and allows the fault to be detected at all of the clock cycle of the sequence. Such sharing a test of non-meaningful with conventional scan-based test, especially when blocks have different number of state variables. Transparent scans thus enhance the ability to produce a compact test set for the group of logical block. The static test compaction procedure described in this paper uses the transparent scan sequence that follows the application of conventional scan-based test precisely. This procedure obtains a set of transparent scan sequence for a group of logical blocks from the compared test set for the logic block in the group. From this set, it selects a subset that detects all the target fault which are detected by the complete set. Under an approach to the test application called transparent scan, the scan test and the scan chain input of the scan circuit are considered as the input of the sequential circuit in the same way of the primary inputs, and the scan chain outputs are considered by the primary process. The scan parents and sequence were allowed to assign arbitrary value to the scan select input. The resultant in arbitrary sequence of the scan and functional clock cycles. Next, we will see the flow diagram for the product. First, the input test patterns. The input test patterns are applied to the S9234 benchmark circuit. The S9234 benchmark circuits, it's a standard architecture. It's a one type of combinational architecture. The combinational architecture mainly based on the NAND gate function. This architecture results are input test patterns. The input test patterns applied to the load state block. The load state block to be controlled by the restore function. The restore function to be activated the scan enable functions. The scan enable function to create the restore operation, then the restore operation to perform the launch and capture block. The launch and capture block is mainly used to the capture the test pattern and to apply the launch of shift processing elements. The LOC block is mainly based on the number of input test patterns. Thus the 11 test patterns to be applied for the process. The 11 LOC block is to be processing by the our testing architecture. Thus the architecture to pass the interface register. Interface register is one of the without clock register element. It's a latching process to be applied. Thus the input to be just storage the interface register and to pass the shadow. The shadow register is finally considered by the final test pattern results. The final test pattern results to store the shadow register and to apply the launch and shift operation. This launch and shift operation to be activated by the scan input signal. The scan input signal to be set, the launch and shift operation to be processed. The launch and shift operation at the same time the shadow register to be applied the last bit and to compare the XOR gate function, then the expected input to be processed and the scan input to be applied. Thus the two input to be considered, and finally we calculate the fault detection process and the output to be calculated by the synthesis and simulation results processing. And finally we discuss about the output for the product. Just open the Xilinx ISC project. Our design and testing product is developed by the VHDL language, and we follow the structural modeling for developing our design and testability architecture. Next we select the simulation, and to double click the simulate behavioral model process, just we simulate the our LOC architecture. Then the process is simulate behavioral model is completed successfully, and to create the ISM simulator graph, just we apply the processing results. The scan input to be applied by the process, just the scan input. Clock initially to apply the 0 processor, then the scan enabling process to be activated. The benchmark circuit input is to apply the any of the input. We just run for the time specified on the toolbar. Next we apply the clock 1 results. Then to activate the scan input signal and deactivate the scan enable signal. Play the clock fully. Then we output the output test pattern results, and finally fault detecting signal to be 0 for the simulation result. We just certify the testing architecture simulation result. Then to calculate the implementation process, then create the view RTL schematic, add and create schematic. This is our the LOC and LOS based testing architecture. Just we develop the benchmark circuit and the overall combinations for the RTL diagram. The RTL diagram which represents the what are the logical blocks placed in our testing architecture. Then we go to the technological diagram. The technology diagram to represent the what are the lookup table and flip-flop pairs, then input output connections are placed by the in our testing architecture. Then go to the design summary process. The design summary process, we select the synthesis report. The synthesis report mainly used to the area and timing calculation. This is our the area for the testing architecture. Then we calculate the time for the path delay 1.167 nanoseconds for our the testing architecture results.